Chapter 2 of our production possibility frontier module, we are going to start looking at an example to help us better understand exactly what I'm talking about and referring to in our production possibility frontier. So let's get started right away with an example, and as we move through, I'll try to address some of the common questions that I often hear when we're talking about the production possibility frontier. All right, so let's look at our first example here, and our first example deals with some information from the United States. And remember, when we look at our production possibility model, we make some pretty big assumptions, and our first assumption is that we have full employment. I'm going to talk about what that means in just a minute, but let's continue on. We also assume that we have fixed resources and fixed technology. So we're going to assume that all resources in the economy are fixed. There's not new resources coming. People can't be productive. They're not getting an education over the time span in which we're looking. And the one piece that's really important, really relevant to us, is the 50,000 hours of labor available each month to our economy. And so we're going to use those 50,000 hours of labor to produce two goods, our final assumption for our production possibility frontier. In our example, we're going to look at computers and wheat. And so producing one computer requires 100 hours of labor. Producing 1 ton of wheat requires 10 hours of labor. So we can start to get at, okay, how much labor are we going to contribute to computers versus wheat, and then determine, okay, with those allocation of labor hours, how much can we produce? So let's look first at if we spent all of our time producing computers. So if we spend all of our time producing computers, that means we're putting 50,000 hours towards the production of computers. And so if we spend 50,000 hours building computers, how many computers can we build, right? That's the question. How many computers can we build? And so to determine that, what we're going to do is we're going to put the number of hours total. So the number of hours that I'm in total going to use to build computers, and I'm going to divide it by the number of hours to produce one. Okay, and so what that means is if I spend all of my time, all of my labor hours, my 50,000 hours of labor producing computers, and it takes 100 hours to produce a computer, well, let's knock off two zeros. 500 divided by 1. If I spend all of my time producing computers, I can produce 500 computers and no wheat. Okay, so if I spend all of my time producing computers, that means I'm spending my 50,000 hours of labor producing computers. I can then produce 500 computers, that's 50,000 hours, total hours, divided by the amount of time it takes to produce one computer, and I produce 500 computers. There's no time left to produce wheat, and so I produce no wheat. All right, what about if I spend all of my time producing wheat? So now let's go to the other end. I'm not spending any time producing computers. I only want to produce wheat. And so I'm going to take my total number of hours, labor hours, that's 50,000 hours, and I'm going to divide it by the amount of time it takes to produce 1 ton of wheat, which is 10 in this case. And so to get that, then I can get rid of my ones there. I can take 5,000 then divided by 1, and we can see if we spend all of our time then producing wheat, we can produce 5,000 tons of wheat and no computers. And that's my second option here. I could do that, and I'm actually going to put that in option C. I could spend no time producing computers, spend 50,000 hours producing wheat, and that will allow me to produce 5,000 tons of wheat. All right, and then finally, what if we decide to use half of our 50,000 hours of labor to produce computers and the other half to produce wheat? So I'm using half of my labor hours to produce computers, the other half to produce wheat. And so that means I have 25,000 hours available to produce computers, and I have 25,000 hours available to produce wheat. And so if I want to know first how much wheat or how many computers I can produce, If I take my 25,000 hours, which is just the 50,000 divided by 2, if I take 25,000 hours and divide it by the 100 hours it takes to produce one computer, I can see that I'm going to be able to produce 250 computers. All right, and then what about wheat? If I spend 225,000 hours producing wheat and I produce 1 ton of wheat in 10 hours, I can produce 2,500 tons of wheat. So I can produce 2,500 tons of wheat and 250 computers. All right, so what we have here is 250 computers, 2,500 tons of wheat. And so this is what we call that production possibility frontier schedule. So all it does is it lists those different production combinations for me, so I know what is our productive capacity. So I could produce 500 computers and no wheat, 250 computers and 2,500 tons of wheat, or I could produce no computers and 5,000 tons of wheat. And so those start to build those production possibility frontier. All right, so now let's start to graph these so we can look at our production possibility frontier the way you'll typically see it viewed, which is as a curve. And so we can first put on our label A, and this is going to be producing 500 computers. And so we're going to produce 500 computers. So we're going over to 500 here, and no wheat. So we spend 0 time producing wheat. And our first point, point A, falls right here, 500 computers and no wheat. All right, in our next slot, we have 250 computers, so we're operating right about there. Make a little line there. And then 2,500 computers, so right there. And I can estimate that point B to be right about there. That's my point B. And then my final, I'm producing no computers, so I'm still right over there, and I'm producing 5,000 tons of wheat, and so I'm right there with C. All right, so now I have my points A, B, and C, and I could calculate more along the way. What if I spent 75% of my time producing computers and 25% of my time producing wheat, and vice versa? And I could build more points within this production possibility frontier. I'm not going to do it out of the interest of time, but just note that you could. Any combination in which you're producing computers and wheat so that it adds up to 50,000 hours of labor is going to fall on this production possibility frontier. All right, so let's connect these points here, and I'm not going to be able to draw a straight line, so forgive me, but know that that line should be straight, and you can draw it straight on there with your graphing calculator or ruler if you're doing it by paper. But this is our production possibility frontier. At any point along this production possibility frontier meets those assumptions that we've made. It means that we have full employment, we have those fixed labor, capital, entrepreneurial ability, and land, and there's no technology occurring, and then of course we have 2 goods. Okay, so all of our assumptions are met when we're on our production possibility frontier. As soon as we start to move away from our production possibility frontier, something has happened. And so let's start to talk about, okay, what happens and why is it that our production possibility frontier is so special? So the first thing that I want to introduce into our production possibility frontier is the idea of opportunity cost. So, well, at this point, point C, we're producing wheat and we're producing computers, right? So we've got wheat, we've got computers, or sorry, we've got wheat, we've got no computers at point C. Well, we want some computers, and to be honest, I want 250 computers. I want to be out here. I want 5,000 tons of wheat and 250 computers, right? That would give me 5,000 tons of wheat and 250 computers. That would be wonderful, wouldn't it? Why can't I be at this point? And we can call it point D for ease. So why can't I be at point D? Well, let's see how many labor hours it takes me to produce point D. Well, I want 5,000 tons of wheat, and we know it takes 10 hours to produce that, and so that's 50,000 hours. So we're already at our maximum capacity. An additional 250 computers, and we multiply that by the 100 hours it takes to produce a computer, and all of a sudden it took us 25,000 hours to produce those computers. And so we would need, if we wanted to operate at a point like D, 75,000 hours available to us. However, our production possibility model tells us that we have fixed resources. We can't get to 75,000 hours of labor. And so D is not possible. So if we want 250 computers, it's going to cost us. And it's going to cost us, we're going to have to move down to B. And so there's going to be some loss here. And the loss is going to be in terms of wheat. We're going to lose 2,500 tons of wheat if we want to gain those 250 computers. This 2,500 tons of wheat is the opportunity cost of those computers. So to earn that extra 250 computers, I had to give up. What was my next best option? It was to use those labor hours to produce 2,500 tons of wheat. And so the opportunity cost of producing 250 computers was the loss that I had here in terms of wheat. But we could also move in the opposite direction. So let's say I'm operating down here at point A, 500 computers and no wheat, and I wanted some wheat. So I want to produce wheat. Again, I can't just produce 500 computers and 2,500 tons of wheat. That option, if you would calculate it out, again, would not be feasible. It wouldn't be possible under that 50,000 hours of labor. And so I have to give something up. And in that case, I have to give up computers. So I have a negative 250 computers. So when I move from point A to point B, so when I move in this direction, I lose computers. There's a loss of computers, and I gain those gain that wheat. So it is going to be important to determine, am I moving from A to B or B to A? So make sure you pay attention to that when you're looking at your production possibility frontier and the opportunity cost. But as you move, note that you can't move beyond the production possibility frontier. And the reason why we can't get to these points outside the production possibility frontier is that they're what we're going to call unattainable. They're unattainable because we do not have enough resources to move beyond our production possibility frontier. At any point outside our production possibility frontier, we do not have the amount of resources available to us. Okay, what we're going to see is that our points on the production possibility frontier, well, they're definitely attainable, right? We can see that these points were attainable. We developed them based on this 50,000 hours of labor. And since we have full employment has to occur when we're on the PPF. Then that means that we're not only at attainable points, but we're also efficiently run. So we have efficient, attainable points at points like A, B, and C. Those are attainable and efficient. What we're going to find, and we're not going to talk about it specifically in this section, but is a point inside the production possibility frontier. A point like C is going to cause us to be attainable. We can produce that. We have enough labor hours, but it's not full employment. And so since we're not using all of our resources to produce those goods, we have resources that are unemployed. We're not sitting at a full employment level. They're attainable, but they become inefficient. So a point inside the production possibility frontier is attainable, but inefficient. Okay, so at this point, if you're fuzzy on anything, how I did any calculations or anything like that, I want you to stop and re-watch this part of the lecture, because it's only going to become more difficult as we continue to work through the different problems. I would also recommend, if you still have troubles, to send me an email. I have many resources going through production possibility frontier, or if it's a specific question, you can always send me an email. All right. So let's do a quick quiz. Suppose the United States produces 300 computers. How much wheat can they produce? Suppose the United States wishes to produce 400 computers and 2,000 tons of wheat. This is blank. All right, so I want you to hold off here, and I want you to go through those questions, see if you can answer them on your own. Once you're ready, continue on and see if you got the correct answer. All right, so hopefully you paused and you went through these questions. All right, so for the first one, suppose that the United States produced 300 computers. How much wheat can be produced? Well, the first thing we need to do is determine how much time do we have to allocate towards the production of wheat, right? We don't know what we're going to divide by 10 to get the total amount of wheat that we have access to. So to determine how much time we have to produce wheat, we have to figure out, well, how much time do we spend producing computers? And so how much time do we spend producing computers? Well, we produced 300 computers, and it took 100 hours to produce each one. So we have to multiply those together, and we're going to see it took us 30,000 hours to produce those computers. So we have 30,000 hours devoted to computers, and we had 50,000 hours total. So we had 50,000 hours total, and if we've already used 30,000 of those hours, that means we have 20,000 hours left for the production of wheat. And so that's what we're then going to stick in. We have 20,000 hours available for us to produce wheat. It takes 10 hours to produce 1 ton of wheat, and so that leaves us with 2,000 tons of wheat. And so another point that we could go back and look at on our production possibility frontier would be the point at which we'd have 2,000 tons of wheat and 300 computers. So that would fall about right there. Okay, so another point on our production possibility frontier, again, we have to figure out how much time we're devoting towards the production of computers. After we determine that we're using 30,000 hours to produce computers, we see how much time do we have left for wheat, and in that amount of time, how much wheat can we produce? Okay, finally, suppose that the United States wishes to produce 400 computers and 2,000 tons of wheat. How would we describe this point? Well, to produce 400 computers, we know it takes 100 hours to produce one, so that's 40,000 hours that we're devoting towards the production of computer. So I'm just going to call those computer hours. Lost the P there. And then we have 2,000 tons of wheat, and it requires 10 hours to produce 1 ton of wheat. And so that would be 20,000 hours, and we'll call that wheat hours. And so in total, it would require us 60,000 hours to produce this allocation of computers and wheat. But we don't have 60,000 hours available to us. We only have 50,000 hours. So this point is beyond the PPF. It's too far out there. And so it is what we call unattainable. It's not even possible to produce this quantity. And so we have an unattainable point. Our economy can't support that level of production. All right, so now what I want you to do is go through and work this problem out for Japan. So again, I want you to do more practice with this topic. I'm going to move through this one rather quickly to make sure that you can fully understand the material, but what I want you to do now is to pause this problem and go through and see how well you can do on your own. All right, so hopefully you've paused and you've gone through and worked this problem out. And so let's just use again our A, B, and C. I'm going to use as let's produce all computers, and then half and half, and then all wheat. All right, so if we spend all of our time producing computers, we're taking all 30,000 hours. So Japan has less hours available to them. They only have 30,000 hours, and it takes them 125 hours to produce a computer. So when we take our 35,000 and we divide it by 125, we get 240 computers. So if we spend all of our time producing computers, we can produce 240 computers and no wheat. Okay, on the other side, if we decide to produce all wheat, we can take our 30,000 hours of labor, and I'm just going to put 30K, and we're going to divide that by 25 because it takes them 25 hours to produce 1 ton of wheat. So if we spend all of our time producing wheat, we can produce no computers, and we can produce 1,200, whoop, I got off the screen there a little bit, 1,200 tons of wheat. All right, what about half and half? So that means we're spending 15,000 hours producing computers, so that's 125. 15,000 divided by 125, and then another 15,000 hours towards the production of wheat, and that would be 15,000 divided by 25. And what we see here is that's 120 computers and 600 tons of wheat. So let's do a quick labeling here. So I'm going to say about here for point A, and then add 120 computers and 600 tons of wheat. Oh my goodness, I'm really far in there. That would be about B, and then just over the 1,000 mark for C, and we can draw in that production possibility frontier for Japan. Okay, so again, a much smaller scale here, but what we see is that same idea of a production possibility frontier. Points on the production possibility frontier, even if we didn't label them, are going to be efficient points where we're using all 30,000 hours of labor available to us. Okay, and then we can think about opportunity costs as we move from point C to point B. To get more computers, we have to give up wheat. And this negative slant here shows us how much wheat we have to give up. And the same idea here. If we decided we wanted even more computers and no wheat, we'd have to give up even more. We'd have to get even more computers. We'd have to give up even more wheat. And we can just see all of that opportunity cost. Each time we get more computers, we give up more wheat. All right, so hopefully you've got a basic understanding of the production possibility frontier and how it's calculated, what the chart looks like, and now start on reading it. We're going to continue on and go further into reading it and then start to loosen the assumptions of our production possibility frontier. If you need more help on practicing this building of the production possibility frontier, which will be on your quizzes and exams, make sure you check out the more practice folder. All right, I guess before we conclude, I do want to go back and just reiterate. So we have a production possibility frontier. It looks a little different to the one that we discussed so far, but it is bowed outward, and that's what we're going to talk about in our next lecture, is that idea of a bowed production possibility frontier and what that means. Okay, so any point on this production possibility frontier, and I'm just going to label a few more, so F and G, any point F, C, B, A, and G, these points that are on our production possibility frontier, they're what we call attainable and efficient points. They're attainable and efficient. And they're attainable and efficient, again, because we can produce them. That's why we call them attainable. And they're efficient because they're using all of our labor hours available to us. A point like E is unattainable. It's not possible, and I'm not spelling that right, but that's all right. Unattainable, it's not possible to produce E because it's beyond our production possibility frontier. We don't have the labor hours, we don't have the factors of production to reach out to point E. Okay, what about point D? Point D is possible, it is attainable, but it's inefficient. Okay, point D is inefficient because we could, at point D, use some of those resources that aren't being productive, and we could produce more, in this case, trucks. We could produce more trucks, and we don't have to give up any boats. Or we could produce more boats, and we don't have to give up any trucks. Or we could produce more of both goods, at zero opportunity cost. At a point like D, a point inside the production possibility frontier, no matter where it is, if it was there, if it was down here, if it was in here, if it was just right outside, they're all going to be inefficient because we could get more of either good at zero opportunity cost. Okay, more at no opportunity cost. Incredibly important, and many students mess this up. Many students forget that when we're operating inside our production possibility frontier, we can get more at no cost to society. And I don't mean no dollar cost, okay? It will have a dollar cost to society. Somebody's going to have to buy those goods and services, but it will not cost us in that those workers are sitting there unemployed, and if we put them to work, that means we're not losing production of another good. So there's no opportunity cost when we're sitting at a point D, and that's because we're not at that full employment. So at point D, we're not at full employment, and so there's no opportunity cost. We call that attainable or possible, but inefficient. It's an inefficient allocation of our resources. All right, so that actually concludes this lecture. Again, we're going to dive in more in depth into different, making the production possibility frontier more applicable to the real world, and then also thinking about what happens when we start to drop those assumptions.